had a question of a problem that in my book is problem 1145. And this is a problem, I think the person's name is Sam, and they're skiing down an incline of angle 20 degrees. So this angle is 20 degrees, and I believe the mass of the person is 75 kilograms. And they're skiing down this incline. Now the one thing that's a little bit different than we've had typically is there's a wind force of 200 newtons that's blowing completely in the horizontal direction towards this skier. And so we have to figure out how that applies. And what they want you to do is they want you to find the velocity final of this skier. And we assume the velocity initial is 0. So one way to do this is just to say, okay, so the work net equals K final minus K initial. And then we know since the person's not moving initially, that K initial is 0. And in this case, for the net work, we're going to say that it's the force net times the displacement. And actually what I'm going to do is I'm going to do this in the x direction of the surface of the incline. And so here's the actual equation we're going to solve. So we do one of these deals where we draw our incline like this. So this is the y direction, and this is the x direction, that way there. And now what we're going to do that is we're going to break this 200 newtons into its two forces. Okay, and hopefully you can see that this here is that same angle theta. So this guy over here would be 200 newtons times sine of that angle theta, and then this guy over here would be 200 newtons times cosine of that theta. So if I was to draw the free body diagram, we'd have our typical forces. Normal force mg cosine theta, and then here I'd have mg sine theta. And then this 200, we'll break it into two pieces. One piece that's pressing down, which we're not so interested in this problem, but it would be there. So 200 sine of 20, and then this wind force that's basically pushing back on the person in our x direction of 200 newtons cosine of 20. So we have these are the forces, and so our F net then is going to be, I'll call the mg sine theta positive, and then negative 200 newtons cosine 20. So that's our F net in the x direction. The next thing we got to do is solve for our delta x. Now we know that it's 50 meters this way. We know this angle is 20. And so when I calculated it out with a little triangle, so our triangle's going to look kind of something like this here. So here's our triangle. So this side is 50 meters, and this is our angle. I got that our delta x, which is the hypotenuse of this incline, was, I think, let me just check here, 146 meters approximately. And so this would be times 146 meters. And we're going to set that equal to our K final. And so just going through and doing this, again, the mass was 75 kilograms, so you can do this with me if you want. 75 times 9.8 times sine of 20 minus 200 times cosine of 20. Then all of that times 146. So the total work I get being done here is about 9,263 joules equals K final. And of course that would be 1/2 m velocity final squared. And so if you go through and solve for the velocity final, it'll be this 9263 joules times 2 divided by the mass of 75 square rooted. And let me go through and do that. So times 2 divided by 75, square root of the answer. I get 15.7 meters per second, which rounds up to 16 meters per second here. So in problems like this, typically what you want to do is take that horizontal 200 and split it up into x and y of the incline.